Good morning. Here I am going to discuss conduction. So, how can you define the conduction? So, conduction may be defined or may be viewed as a transfer of energy from the more energetic particles of a substance to the adjacent less energetic particle of substance due to interaction between the particles. That is definition of conduction. Clear, beta? So, conduction may be viewed as the transfer of energy from more energetic particle of substance to the less energetic one due to interaction between the particles. ठीक है, and substance may be either solid or fluid. So, conduction may be viewed as a transfer of energy from the more energetic particle of substance to the less energetic one due to interaction between the particles. Clear? And what are the mechanism of conduction? Mechanism of conduction. As far as the mechanism is concerned, they are basically in solids. Conduction is via following two mechanisms. One is lattice vibration, and flow of free electrons. Flow of free electrons. So there are two mechanisms is there for the conduction in the solids. What is lattice vibration and what is the flow of free electrons? These two cumulatively responsible for the mechanism of conduction in the solid. As far as lattice vibration is concerned, what is the lattice? Anyone? Actually, it's atomic activity. Lattice vibration is actually atomic activity. Anyone have idea about lattice? Yes, periodic arrangements of atoms is called as lattice. Okay. So lattice is nothing, it's a periodic arrangement of molecules. In the solids, molecules are fixed at their position in a lattice form, in their lattice structures. So in the solids, if I'm talking about the arrangements of the molecules or atoms in the solids, so basically in the solids the atoms or molecules are fixed at their position in form of lattice. So lattice is nothing, it's a periodic arrangement of atom. So just I'm going to show you one cross-sectional view of solid. Let's say this is solid here, and here you can view this as a clear. So they are the arrangements of the solid molecules, and this is called lattice structure. So what is lattice vibration? Actually, the molecules on their position, they start vibrate. This is called as atomic activity of the molecules. Atomic activity means conduction in solid attributed to the atomic activity in form of lattice vibration. So there is atomic activity is there in form of lattice vibration. So lattice vibration is simply कि in lattice vibration the atoms of the substance, or you can say the particles of the substance, are start vibrate on its position, है ना? They start vibrates on their position, and when they vibrates, vibration is more violent towards the high temperature side. Clear beta? Vibration is more violent towards the high temperature, and there is a, do you know why temperature? Temperature is a measure of kinetic energy of molecules. Temperature is a measure of kinetic energy of molecules. Higher the temperature, higher the energy is there. Temperature is a measure of kinetic energy of molecules. If the temperature is higher, then molecules will vibrate more violently, more vigorously towards the high temperature side. So as far as lattice vibration is concerned in solids, since molecules are fixed at their position in form of their lattice structure, so molecules start vibrate, and that creates a wave, that induces a wave, and that wave move from the high temperature to the towards the low temperature. If this subject to the high temperature side, high temperature, and this side is a lower temperature, then due to vibration a wave is induced. This is called lattice wave. Okay, so due to vibration, and I told you कि vibration is more violent, more vigorous towards the high temperature side, and that's why the molecules, I told you conduction is simply a transfer of energy from the higher energetic particle to the lower energetic particles due to interaction between the particles. So particles are going to interact in form of vibrations, so they transfer the energy in this way, and this causes the transfer of energy in form of lattice wave. Clear? A wave is induced due to vibration, and that wave propagate from the higher temperature to lower temperature, and that transfer the energy as well. Is this clear? So this is what the lattice vibration, how the conduction is taking place in the solid due to lattice vibration. Clear? So molecules are not moving from their position. Molecules on their position, they are fixed because they are they are solid. So in solids, molecules position or atom positions are fixed, and on their position they start vibrate, and vibration is more violent, more frequent, and more vigorous at the higher temperature, because temperature is a measure of kinetic energy of molecules, and that vibration induce a wave, and that wave propagate from the higher temperature to lower temperature, and this way due to interaction in form of wave, and they transfer the energy from the higher energetic to the lower energetic one, and that is causes the conduction in the solids. This is one reason. Second is what the flow of free electrons. So free electrons, or you can say translational motion of free electrons. So as far as translational motion is concerned, the in electrons, if I'm talking about the metals, if I'm talking about the metallic solid, so in the metals always the large number of free electrons are there. So, and the free electrons are moving. Free electrons, a large number of free electrons are there, and when they move, they also carry the, during its movement, they also transport the energy from the high temperature to lower temperature. So due to free electrons, due to flow of free electrons, or due to translational motion of free electrons, because here the free electrons are there, free electrons. So as the free electrons moves, they also carry the energy with it. The two reason is there for the conduction in the solids. One is lattice vibration, and other is flow of free electrons, because in the metallic solids there are large number of free electrons are there, and as the free electrons are moves in the solids, they also carry the energy with it. and hence they act as a transporter of energy from the higher temperature to lower temperature. Is this clear? So they are the mechanism of conduction in the solids. Two mechanisms there: flow of electrons and the lattice vibration. Now, which out of two mechanisms, which one is dominating in the case of metals? In metals, the most of the conduction is through flow of electrons. Means approx 90% of the conduction, 90% of the energy transfer is due to flow of electrons, and 10% is due to lattice vibration. So you can write, from your own. In the metals, most of the energy transfer from the higher energy to lower energy is due to flow of free electrons, and less than 10% is due to lattice vibration. Now, in case of non-metals, which one is dominating? Energy transfer is due to lattice vibration only, because in the non-metals the number of free electrons are very few or nearly negligible. That's why most of the energy transfer through conduction is via lattice vibration. Okay. So there are two mechanisms there in the case of solids. Now, mechanism of conduction in the fluids. Basically, in liquid and gases the mechanism is common. That's why I am writing here in fluids. Means either liquid or gas. I am talking about mechanism of conduction in fluids. So in the fluids the mechanism is common, and that is what? Molecular diffusion. So do electrons move randomly? That you should answer from your own. What about you people? This is the class 10th question about the physics. Molecular diffusion and collision. So the better word should be molecular collision. Molecular diffusion and collision. So my dear student, this mechanism can be very easily understood. For example, this is what the molecular diffusion. What is molecular diffusion? Random motion of the molecules. It's simply random motion of the molecules is called as molecular diffusion. Random motion of molecules is called as molecular diffusion. As you know, in the case of gases, first of all I will talk about the gases. In the gases, molecules are moving randomly. Yes or no? Random motion is there. Random motion of molecules is there in the case of gases. So let us consider a gas in which temperature gradient exists, and assume that there is no bulk or microscopic motion. There is no bulk motion, or either there is no macroscopic motion. No bulk motion or no macroscopic motion is there. So you know, temperature is a measure of kinetic energy of molecules, and every molecules are going to move randomly by the virtue of its thermal energy. Every molecules have some kinetic energy, yes or no? So due to its energy, the molecules are moving randomly. High the temperature, high the energy, and due to high velocity the molecule will get move. Yes or no? So molecules will move with the higher velocity if temperature is high, because temperature is a measure of kinetic energy of molecules. High temperature are associated with the higher molecular energies. So when neighboring molecules collide, as they are constantly doing, the transfer of energy from the more energetic particle to the less energetic must occurs. Yes or no? By how the diffusion and collision are responsible for the conduction in the fluids. As I told you, conduction is nothing, it is a transfer of energy from the higher energetic particles to lower energetic particles. So as you know, let's say this is what the plate is there. Now here temperature is T1 and here temperature is T2, and T1 is more than T2, and when T1 is more than T2, then there is no any buoyancy effect, and there is no any natural convection will be there, because T1 is more than T2, then lower density fluid is at the upper and higher density fluid is at the bottom. There is no any convection current is there. That's why, because in order to have a carry out conduction, we should assume that there is no bulk motion or there is no microscopic motion. Okay beta. So what happened, as you know, the molecules are randomly moving. So listen, we have just considered one reference plane as x0 as a position here. What we have seen, any molecules above the plane x0 are towards the high temperature side, and when they moving towards the bottom side, they will transfer energy as well, because they are coming from the higher energy region, because temperature is higher. And at the same time, any molecules below the reference plane, if they are moving in the upward, they are coming from the lower temperature region to the higher temperature region, yes or no? But as we know, the temperature is a measure of kinetic energy of molecules. So here the motion is random. Some of the molecules coming from the high temperature and they enter in the low temperature region, and some of the molecules randomly move from the low temperature to high temperature, yes or no? Good morning. गुड मॉर्निंग, पहले गुड मॉर्निंग बोलिए। हाँ थैंक यू। ये क्या है, व्हाट इज दिस? अच्छा बोल दीजिए झंडा ऊंचा रहे हमारा। कहाँ है झंडा आपका? जाइए मम्मा से मांग लीजिए झंडा, बाहर है मम्मा। पैर छू लीजिए पापा का। आयुष्मान बाबा, यस जाइए, मम्मा बाहर है। लिसन, T1 is more than T2. So as the motion of the molecules are random, some of the molecules from the high temperature can also enter in the low temperature, and from the low temperature also they can enter in the high temperature region, yes or no? That is possible, but the net energy transfer from, but there is a net transfer of energy, that is from the net transfer of energy is there from the high temperature to low temperature region. Is this clear? Yeah. So due to random motion of the molecules, the energy transfer is from the molecules may transfer from the high temperature to low temperature and low temperature to high temperature as well. Both is possible because the random motion is there. Are you getting a point? Random motion is there because molecules are moving randomly. That's why due to random motion, some of the molecules, due to the random motion, molecules from the above are associated with the high temperature than those from the below. Yes or no? So in which case there must be a net transfer of energy in the positive x direction. If I am talking here, this is the positive x. So in positive x direction there is net energy transfer is there. Now, so even the collision is not there, my dear student. Listen, even in the absence of collision, there is a transfer of energy is possible. Yes or no? Because as the molecules, I told you, even in the absence of collision, is this possible to transfer of energy? Even in the absence of collision, although let's say if there is no collision is there, still the molecules are diffusing here and there randomly, and that's why due to random motion of the molecules, there is a net transfer of energy from the high temperature to low temperature, and that's called as a molecular diffusion. Yes or no? Random motion of molecules. Due to random motion of the molecules may cross the hypothetical plane x0 from the bottom top and top to bottom as well, but there is a transfer of net energy from the high temperature to low temperature. Now, what is the role of collision? Molecular collision is there as the molecules are going to collide due to in their random motion. During their random motion, there is a probability of molecules may collide to each other, and when the molecules are going to collide, obviously after collision they will transfer their energy. Yes or no? So actually when the collision will also take place along with the random motion, that collision will enhance the energy transfer. Clear beta? So when the collision is there, that molecular collision will, when the molecules are going to collide during their random motion, and then when they collide they will transfer its energy to the other molecules, and this is the way. It means to do collision, the transfer of energy can be enhanced due to molecular diffusion. Actually the collision is a sub part of the diffusion, because during diffusion obviously the collision will be there, yes or no, and when the collision will also takes place, then the net transfer energy can be enhanced. So that's why in the fluids there is following two mechanism is there for the conduction: diffusion and collision. But in this case the only restriction is there should be no any bulk motion, or there should be no any macroscopic motion is there, that should be absent. Same thing with the liquid. In the liquid, if I'm talking about the liquids, in the liquids the molecules are closely spaced to each other as compared to gases, yes or no, because intermolecular force of attraction is much more stronger in the case of liquids as compared to gases. So if you talk about, if you want to increase the rate of heat transfer via conduction in the gases, what we should do? We should increase the temperature. When the temperature increases, the molecular velocity increases, because temperature is a measure of kinetic energy of molecules. More the temperature, more the kinetic energy, and the more the kinetic energy means more the velocity is there. The molecules will move with more velocity, and there is a more higher rate of heat transfer is there via conduction. So as we increase the temperature, if I'm talking about the gases, listen, how can I increase the rate of heat transfer via conduction in gases? First, by increasing the temperature. Second, I told you कि if collision will also get increased, then the rate of heat transfer will also get increased. We can enhance the rate of heat transfer via conduction if the collision will also be takes place. How can I increase the collision? Obviously by increasing the temperature. If more temperature is there, then the molecules will collide with a high velocity. How can I increase the number of collision? We can increase the number of collision by decreasing the pressure or increasing the pressure. How increasing the pressure increase the number of collisions? Yes, by increasing the pressure the mean free path get decreases, and mean free path is nothing, it's a intermolecular distance, or you can say statistical distance between the two molecules for the collisions. Okay, but in the case of liquids there is no such theory is there. So how I can increase the thermal rate of heat transfer via conduction in the liquids, that I will discuss later on. Clear? So this is what the mechanism of conduction in the solids and the liquids. Any problem beta? Now as far as example of conduction heat transfer is concerned, there are various example is there, various example of conduction is there. For example, if you expose the end of metal spoon suddenly immersed in a cup of hot coffee, that will get eventually warmed due to conduction only. Because let's say you might have seen, let's say this is a hot cup of coffee is there, and if you place a steel spoon, then you might, if you expose the spoon, if you expose the end of metal spoon suddenly immersed in a cup of hot coffee, that eventually get warmed. This side will get warmed. How it is possible? Although this end is not exposed, only this end is exposed within the hot cup of coffee, but this end also get heated. How it is possible? It's just via conduction. Because I told you, when this end of the spoon is put in the high temperature, then due to vibration, because it's about conduction in the solids, then the two reason is there. One is flow of free electrons, and the conduction is there, and the vibration is there, lattice vibration. Then due to vibration and due to flow of electrons, the energy get propagated, and this causes the transfer energy from the high temperature to low temperature, and immediately this side will also get heated. Is this clear? This is the conduction. on a winter day there is significant energy loss is there from the heated room to the outside. Yes or no? In the winter season, if you keep your room at a high temperature via heater or via blower, then if you switch off the heater or blower, immediately the temperature will get down. How it is possible? Because energy from the room is going to transfer from the high temperature to low temperature, which is the outside. The energy get transferred from the inner side to the inside the room to the outside surrounding, which is maintained at the low temperature, and this is via conduction through the walls. So through the walls, the energy is transferred through conduction. Is this clear? So this loss of energy is from the inside the room to the outside. That is because of conduction heat transfer through the room of through the wall, basically. Okay. So there are various example is there of conduction. So that heat transfer processes can be quantified in terms of appropriate rate equation. So what is the rate equation for the conduction heat transfer? That is given by Fourier's law. And the Fourier's law just define he quantify the heat transfer in terms of amount of energy transfer per unit time. Amount of energy transfer per unit time. Okay. And that is called as Fourier's law. So by the Fourier's law of heat conduction, this is the rate equation for the conduction. Rate equation for conduction, and that is what Fourier's law, given by Fourier's law for one dimensional plane wall, or you can say in simple, heat flux. What is heat flux? What is flux? Anything that is transferred per unit area per unit time. Any amount of transport quantities, amount of transport properties that transferred through unit area unit time is called as flux. So here transfer property is heat. So amount of heat that transfer through unit area unit time is called as heat flux. Clear beta? So by Fourier's law, the heat flux, so heat flux I am going to define with the Q, a small q. X, and this is watt per meter square. X is the direction. So the heat flux is the transfer of rate. Heat flux Qx is the rate of heat transfer is the rate of heat transfer per unit area. Now you can become flux. Huh? The rate of heat transfer per unit area is called flux. The rate of heat transfer per unit area perpendicular to the area must be perpendicular to direction of transfer, and it is proportional to the temperature gradient. dt upon dx in this direction. Clear? So what the Fourier's law is that Fourier's law is used to define the rate of heat transfer through conduction, and that simply says that flux Qx is the rate of heat transfer per unit area perpendicular to direction of heat transfer is proportional to the temperature gradient in this direction. So if I am talking about the heat transfer in x direction, because heat transfer is a vector quantity, that's why we must define the direction. So the heat flux Qx, x define the heat transfer per unit area in x direction. So heat flux, which is the rate of heat transfer per unit area perpendicular to area, must be perpendicular to direction of heat transfer. It is proportional to the temperature gradient in this direction. Is this clear? So what you can write here, Qx proportional to, or Qx proportional to dt upon dx, and dt upon dx nothing is temperature gradient in this direction of heat transfer. Okay, or if you remove this, Qx is equal to minus k into dt upon dx, where minus indicates u temperature get decreases in direction of increasing x? Yes or no? This minus sign only indicates temperature get decreases in direction of increasing x. Minus sign indicates temperature decreases in direction of increasing x. Clear? And this is the flux, and the flux is nothing, it's the rate of heat transfer upon per unit area. Area is normal to direction of heat transfer, AX. Then you can also write the rate of heat transfer is equal to flux into area at that x, and this is minus k into AX into dt upon dx. Below, is this clear beta? Where AX is the area normal to direction of heat transfer at that x. Clear? Any problem? Where K is called as thermal conductivity, where this K is called as thermal conductivity. And this is the characteristic of material. It is and is characteristics of material, of substance, you can say, of substance. Means every, for example, what I'm saying to you, what Fourier has found, observed, कि if the same temperature gradient we maintain and same area is there, but still the rate of heat transfer is different for the two different materials. It means the rate of heat transfer does not only depend upon the area, does not only depend upon the temperature gradient, it also depend upon the material, and that material have different, every material have different ability to conduct the heat, and that property of the material should be taken into consideration by a property name is called as thermal conductivity. Clear? For example, if here, let's say this is what the metal wall, this is what the wall is there. Clear beta? Try to understand. If I'm talking about one dimensional heat transfer, this is what x, and this is its temperature scale. Here temperature is T1 and here temperature is T2. This side, this left face and right face is at temperature T2. Left face is at temperature T1, right face of this material is temperature T2. And if I'm talking about the rate of heat transfer in x direction here, then if I'm considering here, let's say any x plane here, this is at 0 and this is what x here. At any x, the area normal to direction of heat transfer is AX. Clear beta? And temperature gradient at this point is, let's say, dt upon dx. Dt upon dx is nothing, temperature gradient, and temperature gradient may be changed from location to location, that depend upon the conditions. So let's say temperature gradient at this position is dt upon dx, which is the slope t versus x. Yes or no? So dt upon dx is negative, but when I put it in the minus, multiply with the minus sign, this becomes positive. That's why I write it here in terms of q here. Okay. So listen. So dt upon dx is negative, and when I multiply with the minus, it becomes positive, and that will give you the positive rate of heat transfer. So meaning is that, my dear student, कि dt upon dx here, and area at that point is normal to direction of heat transfer is AX. AX is area normal to direction of heat transfer. Okay, and let's say if I change the material from the steel to copper, then what happened? Is keeping the same dt upon dx and same area. The dt upon dx is same, means temperature gradient is same, area is also same, but still the rate of heat transfer is different, and it's just because of material has been changed. So it means every material have different ability to conduct the heat, to propagate the heat, and that property of material of the ability to conduct the heat should consider in the equation of Fourier's law, that is given by the, that has been considered by the property of the material name is called as thermal conductivity. So what is the physical significance of thermal conductivity? The thermal conductivity is nothing, it's simply ability of the material, it's a characteristic of the material to conduct the heat. Every material may have different ability to conduct the heat, and that ability of the material should be taken by a property should be taken into consideration by using a property name is called as thermal conductivity. Is this clear? So this is what the inherent property of the material. Clear? Now, my dear student, at the same time, what I am saying to you, so how can you define the thermal conductivity? In order to define thermal conductivity from this equation, we can say the thermal conductivity is equal to heat flux when the temperature gradient is equal to 1 unity. Otherwise, from this equation, we can also say, from this equation, the thermal conductivity means, let's say, if area is 1 unit and dt upon dx is also 1 unit, then can I say q dot x is equal to k? Yes or no? Means thermal conductivity can be defined as the rate of heat transfer through a material of unit area and unit temperature gradient, where the temperature gradient is unity. Yes or no? So actually, from this equation you are able to define the thermal conductivity. Thermal conductivity of a material is rate of heat transfer to that material, or you can say thermal conductivity is equal to rate of heat transfer to that material if the material have unit area and maintain with the unit temperature gradient. Clear? Okay, what happen if, let's say, this is the wall, and I'm talking about x direction here. Its temperature is here. This axis is of temperature. If profile is, if dt upon dx is linear, if dt upon dx is constant, what is meaning of constant? In which case it is constant, that I will discuss later on. Let's say this is what the wall is there, through which the heat transfer through conduction is taking place, and dt upon dx is constant. Then by Fourier's law, if dt upon dx is constant, and here temperature is T1 and here temperature is T2, and in this case you have also seen ki area, actually this is material in this way. So area normal direction of heat transfer is also same. Yes or no? This area at each x is same. Yes or no? Area at x equal to 1, 0, 1, 2, 3, 4, at all x the area perpendicular to direction of heat transfer is same. Yes or no? Bolo. Which area I'm talking about? Do you know? Area normal direction of heat transfer. Just you can place your book. Just you can consider this is your book is there, and just you can place your book in this way. And if I'm talking about this as x direction, then normal area is this one. This is area is normal direction, and this area is same. In this example, the area is same. So when the area is constant and dt upon dx is also constant, then from the Fourier's law, q dot x is equal to minus k a into dt upon dx. Then q dot x into dx is equal to minus k a into dt, because area is not function of x here, area is constant. I can integrate when x equal to 0, temperature is T1. When x equal to, let's say, L is the thickness, then temperature is T2. Then what is q dot x? What is rate of heat transfer? This is nothing, you can please check. This is what called as k a into T1 minus T2 upon L, and this is nothing, q dot x equal to T1 minus T2 upon L by Ka. Yes or no? So this is called as rate of heat transfer at steady state, or at any stand, you can say also. So this I can only write when the temperature gradient is, or dt upon dx is constant. So how can define the thermal? Please define first thermal conductivity. Thermal conductivity is equal to rate of heat transfer to the material. If the material have unit area in direction of heat transfer and with unit temperature gradient, है कि नहीं? बोलो. And this equation of the Fourier's law is valid for steady as well as unsteady state. ये जो equation आपने लिखा हुआ है, it has no any restrictions. Listen, in this form of Fourier's law has no any restriction. This equation of this form of equation of Fourier's law, q dot x equal to minus k a into dt upon dx, that you can apply for either. There is no restriction is there. It's simply general law of the Fourier's law that can be used for steady state as well as unsteady state, even for with generation or without generation. Okay, even the k is going to vary with temperature or not, means in all cases you can use this. Clear beta? This is what the general equation of the Fourier's law. So first of all, I told you conduction is simply the transfer of energy, and conduction is possible in the liquid as well as gases as well as in the solids. But in the liquid and gases, if I'm talking about the conduction, then there should be no any bulk motion, or there should be no any microscopic motion should not be there. Clear? Random motion of the molecules will always be there, because we can't, it's a molecular motion will always be there, but there should be no any random there should be no any bulk motion. What is bulk motion? Bulk motion may induce either by external agencies or by the difference in density or buoyancy effect. Clear beta? So this I told you Fourier's law, and the rate equation is given by Fourier's law of heat conduction. Minus sign 1 indicates temperature get decreases in direction of increasing x. K is thermal conductivity and K is a function of temperature. How K is going to vary with temperature, that I will discuss later on. So effect of temperature on thermal conductivity. Okay. So write down please, heading is effect of temperature on thermal conductivity. So thermal conductivity is ability of material to conduct the heat. Its physical significance of thermal conductivity is ability of the material to conduct the how much amount, how fast the energy get, or not fast, it's a how much more amount of energy get transferred under the same temperature gradient and same area, that is measured by the thermal conductivity. The material having more thermal conductivity can transfer more amount of heat in a given unit of time. Okay. Now as the K is, what is unit of K? First of all, before this I should define the unit of K. As far as unit of K is concerned, this is simply unit of flux. Unit of flux upon unit of temperature gradient. Yes or no? Temperature gradient. So as unit of flux is concerned, this is simply watt per meter square. What is the rate of heat transfer, and per unit area is meter square. Unit of temperature gradient is nothing, it's degree Celsius or Kelvin, because difference, it's a temperature gradient dt upon dx, and temperature difference in Celsius and Kelvin is same. Yes or no? So either you can write degree Celsius per meter in SI system I'm talking about. This is unit of K in SI system. In SI system or in MK system. So degree Celsius, or you can also write Kelvin per meter, because difference in Celsius and Kelvin is same. Yes or no? Clear beta? So if you solve this equation, that you found watt per meter per Kelvin or per Celsius. Okay? This is what the unit of thermal conductivity. As far as effect of temperature is concerned, the first I'm talking about for gases. For gases, my dear student, as I told you, in the case of gases, the mechanism of conduction in the gases is to molecular diffusion and collision. Yes or no? And we can increase the diffusion and collision as well by increasing the kinetic energy, and kinetic energy can be increased by increasing temperature. So as temperature increases, kinetic energy of the molecules get increases, and if the molecule kinetic energy increases, then molecules will move much more faster. So random motion will get increases, and due to random motion we have seen the energy has been transferred from the high energy to low energy and low to high, but net transfer is from the high temperature to low temperature, and that was even in the absence of collision, the energy has been transferred due to random motion of molecules. So if the random motion in anyhow, if we are able to increase the random motion of the molecules, and that we can increase by increasing temperature. Yes or no? So if we increase the temperature, let's say any system is there, this is at temperature of 25 degrees Celsius, and in the same system now it is at 35 degrees Celsius, and now 50 degrees Celsius. The as temperature increases, as compared to 35 and 25, the temperature kinetic energy is more, then there is a more random motion is there, then net transfer of energy is comparatively more than 25 and 35. Yes or no? As 50 degrees Celsius. So that's why in the gases, with increase in temperature, thermal conductivity of the gases will get increases. Clear beta? Bolo. Region clear? Any problem? And also with the temperature, collision will also get increases. Now, second, for solids. In solid there is two cases there. One is in metals and in non-metals. Now listen, in metals, most of the, as far as mechanism of conduction in solid is concerned, the two mechanisms I told you, one is lattice vibration and flow of electrons. So in the metals, which one is dominating? 90% of the transfer of energy or transfer of heat due to conduction is via flow of free electrons. So when we are increasing the temperature of the metals, listen, if we increase the temperature of metals, then vibration get increases. The molecules on their lattice will vibrate more violently at high temperature, and that vigorous vibration will hinder the flow of free electrons. Yes or no? Because when the molecules on their position will start vibrate more violently at higher temperature, then obviously they will hinder the flow of free electrons. And since we know that 90% of the energy transfer in the solids of metal solids is through flow of free electrons, which has been disturbed by the lattice vibration, and that's why with increase in temperature, the thermal conductivity of the metals get decreases. Clear? Can you write from your own languages later on? I will write only results, but reason I am discussing here, you should write from your own. In the metals, since most of the energy transfer is via flow of free electrons, and as temperature increases, the molecules vibrate more violently, more vigorously at their position, at their lattice structure, and that vibration hindered or restrict the flow of free electrons. And since most of the conduction is through flow of electrons, which has been restricted, which has been affected due to vibration of the molecules on their or atoms on their position. That's why the thermal conductivity of the metals get decreases with increase in temperature. Clear? Deepika, Chavi, Iti, Asutosh. The thermal conductivity of metals decreases with increase, means inverse relationship is there. Increase in temperature. What about non-metals? What about non-metals, my dear student? Here in the metals, two exception is there. Do you know what? In metals, the two exception is there. I think one is aluminium and other is sun. In the case of non-metals, if temperature increases, thermal conductivity also get increases because lattice vibration increases. Okay, and more heat transfer takes place in the non-metals due to lattice vibration. Well, in metals, I told you, if temperature increases, lattice vibration will increase. In such a manner, they disturbing the path of free electrons, which results in less transfer of heat in large amount of from this thermal conductivity get decreases. Clear? So although some exceptions are there that I will discuss later on, the exception is one, I think aluminium is there. Now in the non-metals, I told you, in non-metals, if temperature increases, so what happen? Most of the heat transfer in the non-metals is through lattice vibration. So as temperature increases, lattice vibration become more profound. That's why the thermal conductivity get increases with increase in temperature. So K of non-metals increases with increase in temperature. Okay, reason clear? This is for solids. Now for liquids. For liquid, there is no such theory as in the case of liquid and gases. So we should only rely over the experiment. So as far as liquid is concerned, my dear student, thermal conductivity in the liquids is indirectly proportional to temperature, inversely proportional to temperature. So it is found from the experiment that thermal conductivity of most of the liquid get decreases with increase in temperature. Okay? Only exception is water. OB up to wait, I'm telling you, up to 130 degrees Celsius, है ना, up to 130 degrees Celsius. ठीक है बेटा. Water is only exception. Otherwise, thermal conductivity of liquids decreases with increase in temperature. Means inverse is there. Exception is water. Is water. Note. K of water increases with temperature till 130 degrees Celsius, and then follow the same behavior. After that, decreases with increase in temperature. Increase in temperature. ठीक है बेटा. So this is what the thermal conductivity variation with temperature. I will give you one sheet so that you are able to know how the thermal conductivity is going to vary with temperature and pressure. Temperature. Okay, now next thing is that out of solids, liquid and gases, which thermal conductivity is highest? So thermal conductivity of solid is obviously higher than liquid, and that is higher than of gases. Clear beta? Thermal conductivity of the solid is much more than liquid, than much more than the gases. And in the solids, there are two types of solid is there. And if I'm talking about the metals and non-metals, in non-metals there is two, amorphous and crystalline. Do you know, Ritikesh? As far as solid is concerned, solid is of two types, metals and non-metals. In non-metal there is two types. One is called as crystalline and amorphous. What is amorphous? What is crystalline? Do you know? Crystalline non-metal and amorphous non-metal. What is these two? Anyone? Crystalline solid is a solid material whose constituents such as atoms, molecules or ions are arranged in a highly ordered microscopic structure. Their structure is highly well ordered. So crystalline solids have regular ordered arrays of components held together by uniform intermolecular forces, whereas the components of amorphous solids are not arranged in the regular arrays. Yes, the difference in their lattice arrangement. An example of amorphous. So basically the difference in form of their arrangements, lattice arrangements. So the components or constituents of a solids can be arranged in two general ways. One, they can form a regular repeating three-dimensional structure. Regular repeating three-dimensional structure, that is called as crystal solids, crystal lattice. And that types of arrangements produces the crystalline solids. Second, they can aggregate with no particular order. Means their molecules, their atoms, their constituents are not arranged in a particular order. While in the crystalline the order are repeating. While in the amorphous the order is not repeating, the order is totally random. And they form the amorphous solids. And amorphous words from the Greek word that is shapeless. They are shapeless. Their shapes are not proper. For example, galena, quartz, pyrite. Can you tell me example of crystalline? क्वार्ट्ज क्या है? What about, yes, diamond, quartz? I think galena as well, na? Yes. So amorphous example is glass. Glass is amorphous. crystalline तो diamond confirm है. Diamond, quartz, so basically what I want to say here, the difference in form of their lattice arrangements. Arrangements are well ordered and repeated order is there in the crystalline, and amorphous the order is not repeated. Means molecular structure is not well ordered, while in the crystalline they are highly ordered. Is this clear? So due to highly ordered structure, the thermal conductivity of the crystalline solid is highest at the room temperature as compared to amorphous, and even with the non-metals, even with the metals. So that's why this is the reason why diamond has well ordered crystalline structure, well ordered lattice structure is there, highly ordered lattice structure is there. Molecules or atoms or constituents are arranged in well ordered form, and they form highly ordered lattice in diamond. That's why at the room temperature diamond has highest thermal conductivity as compared to any of the solids. Is this clear? And due to this property of diamond, the goldsmith is able to identify between the fake diamond and real diamond. Clear? Fake diamond and real diamond. The only difference, the equipment, even the equipment which is used to test the is the diamond is fake or real, that uses the property of thermal conductivity, because diamond has highest thermal conductivity at the room temperature, around 2200 watt per meter per Kelvin. What it means, if thermal conductivity of the diamond is 2200, it means I told you thermal conductivity is equal to rate of heat transfer, na? When the temperature gradient is unity and area is unity, yes or no? So it means if the thermal conductivity of the diamond is 2200 round, it means the rate of heat transfer through diamond is 2200 if the temperature gradient is maintained as unity and area for the heat transfer unity. Clear? Or you can say in SI system with unit, the rate of heat transfer through diamond is 2200 watt, means 2200 joule per second, if the area of the diamond, area normal direction of heat transfer, is 1 meter square and temperature grade is 1 degree Celsius per meter. Is this clear? So diamond has highest thermal conductivity at the room temperature compared to any of the solids. Clear, beta? I will send you one PDF in which you can go through the thermal conductivity of different metals. At least we must know the copper, silver and all, है ना? So that I will discuss. I will send you. Next I am going to start the convection. This is all about conduction. Problem is clear. Now come to convection. Listen, already I told you in the last lecture, my dear student, the convection heat transfer mode is comprising of two mechanisms. Convection heat transfer mode is comprised of or consists of what two mechanisms? As far as, because convection is always takes place in the fluid, that you must know, because convection involves the transfer of energy between the solid and flowing fluid when they are at different temperature. I told you in the last lecture. So basically the convection heat transfer mode is comprising of two mechanisms, and what the two mechanisms is there, along with molecular diffusion, that was in the case of conduction as well, है ना? Because actually the collision is a part of diffusion, that you know. So I will not say you collision as a because collision is sub part of diffusion. When diffusion will take place, collision is always there. Okay, maybe they may not be there, but collision is sub part of the diffusion, yes or no? So what I'm saying to you, two mechanism, it means convection heat transfer mode comprise of two mechanisms, and that is what, in addition to the energy transfer due to random molecular motion and collision. Let's say I'm going to write, in addition to the energy transfer due to random motion of molecule, that is called molecular diffusion and collision, there is also transfer of energy by the microscopic motion of the fluid. The one additional mechanism will come into picture. As we discussed in the last lecture, the mechanism of conduction in the liquid and gases, conduction I'm talking, mechanism of conduction in liquid gases is what? Diffusion and collision. So along with diffusion and collision, there is another mechanism is there for the heat transfer in convection, that is due to bulk motion. Is this clear? Due to random motion, due to molecular diffusion, you can say, due to molecular diffusion and molecular collision, energy is also transferred by the bulk or microscopic motion. Of the fluid. ठीक है, means along with the fluid motion, The two motion is there. One is molecular motion, other is fluid motion. What do you know by fluid motion? Fluid motion means when the whole flow is moving, whole fluid is moving. Fluid, I will discuss it. What do you know by fluid motion? So in the molecular motion, I am talking about the, for example, let's say if the liquid is stagnant, there is no fluid motion, but there is a molecular motion is there. Try to understand. Yes or no? Here in this case, there is no fluid motion, but the molecular motion is there. Am I right? And what is the fluid motion? Fluid motion means when the group of molecules, when aggregate means group of molecules are moving. That's called as fluid motion. Is this clear? When the group of molecules are combined to each other and they form cluster and then they start moving, that's called as fluid motion. Clear, beta? So when you place the water in a pan, so there is no any bulk motion, there is no any microscopic motion, there is no any fluid motion, but there is a molecular motion is there. So what I am talking about in convection comprising of conduction. So can you say this is a mechanism of conduction? This is what the two is a mechanism of conduction. So that's why I told you the last lecture, convection is nothing, conduction along with the bulk motion. When they, so additional to this, and in addition to this energy transfer via conduction, there is also one additional mechanism is there, that is called as bulk motion. So when the conduction is going to be added by bulk motion, that's called as convection. Clear? Now the most important thing is, what is the fluid motion or bulk motion, or what is the bulk motion of the fluid? What do you know by bulk motion of the fluid? What do you know by microscopic motion of the fluid? So the fluid motion is associated with the fact that at any instant large number of molecules, not a single molecules, large number of molecules moving collectively, not individually, moving collectively or as aggregate. What do you know by aggregate? Or as aggregate. And when such motions are taking place, when these types of motion are taking place in presence of temperature gradient, when such motions means when the large number of molecules are moving collectively, so they will also, and when these types of motion are taking place in presence of temperature gradient, that contributes to the heat transfer. Such motion in presence of temperature gradient contributes to heat transfer. Is this clear, beta? So this is the additional mechanism, that additional contribution of the heat transfer in conduction is called as combinedly convection heat transfer. Clear, beta? Clear hai, yes or no? Now it is going to be more clear to you about the convection. Okay, now listen, if let's say I am talking about here the molecules are moving collectively, this is called as aggregate, means large number of molecules collectively moving. When the large number of molecules are collectively moving, so that collective movement of the molecules also comprising of the random motion of molecules. अरे वाह, जय हिंद, जय हिंद करिए. कस के बोलिए, जय हिंद करिए पहले. वाह Okay, this clear? Now listen. So what I'm saying to you, if molecules are moving collectively, then collective movement of the molecules also comprise of the random motion of molecules. Yes or no? So in this case, combined mode of heat transfer is taking place. It means here the heat transfer is taking place collectively through bulk motion as well as random motion. Because the molecules in the aggregate, when the molecules come moving in form of cluster, or when the molecules are moving in form of large number of molecules moving collectively or in aggregate form, when the molecules in the aggregate retain their random motion, because the molecules in the aggregate retain their random motion, that's why total heat transfer is then due to superposition of energy transfer by random motion of the molecules and by the bulk motion of the fluid. Yes or no? It is just similar to, you can imagine like that. Suppose you are in a crowd. Let's say number of persons are there, and they are first, second, third, fourth, five, six persons are there, and they are in the crowd of large number of crowds are there. For example, that is better to understand. If you are in swimming pool, and if you have ever visited the water park, there is a one item is like one activity is like a wave. Wave was there. Wave swimming pool. Wave will induce then that people are going to move from one location to other location. So in that wave, this is the bulk motion of the wave. So through wave we are going to induce the bulk motion, and even in the bulk motion is there, the individual persons are also moving their own contribution. Yes or no? A true contribution is there. One is bulk movement, is it means total movement of the molecules is due to their own contribution and bulk contribution. So when I'm talking about aggregate, means whole liquid of the pool as aggregate, so in that the total transfer is because of bulk motion. When the fluid provide the motion, then persons are moving from one location to other location, and second is also their own position, own contribution. Every individual has its own contribution. Yes or no? That's why I'm saying you just you can imagine like that, so that you can correlate what is the bulk motion and what is the aggregate. Because the molecules in the aggregate, means molecules is the person and aggregate is the whole swimming pool. So molecules in the aggregate retain their random motion, and hence the total heat transfer, and here I am talking about total movement. Total heat transfer is then due to a superposition of energy transport by, what is superposition? Superposition of energy transport by random motion of the molecules and by superposition of energy transport by random motion of the molecules and by bulk motion of the fluid. Yes or no? And my dear student, actually there are two types of flow is there. One is called as convective flow and other is called as advective flow. What is difference in these two? My dear student, convective flow is the combined flow. When the flow, I'm not talking about heat transfer. The two types of flow is there. One is convective flow and other is advective flow. As far as convective flow is concerned, in the convective flow, the both contribution is there. It means individual contribution and bulk contribution. That's called as convective flow. So convective term customarily used when referring to this cumulative transport. So cumulative transport means transport due to random motion and as well as bulk motion. Is this clear? That cumulative transport is called as convective flow. While in advective flow, only if the transport is due to purely what? Bulk flow, that is called advection. Is this clear? Advective flow. So advective flow is purely by bulk motion alone, only bulk motion. While convective term is customarily used, it's tradition to say convection. Whenever I am saying the term convection, So convection is not for the heat transfer only, it's convective term, and from the convective term that mode of heat transfer name is called convective heat transfer. But the convective term, the two types of transport is there, convective and advective. Convective involves the combined transport of random motion, transport with random motion and bulk motion. Combined transport is called as convection. And advection is the transport due to purely bulk motion. There is no any molecular motion should be there. That is called as advective. Clear beta? So how can I define the heat transfer in terms of heat transfer? Convective heat transfer involves the transfer of the energy due to random motion as well as bulk motion. Okay, and since bulk motion were absent in the conduction, that's why it's only called as random motion, that's called conduction. Now as far as advection heat transfer is concerned, so advection heat transfer means when the heat transfer is due to purely bulk motion. Clear? Purely bulk motion. So and how the heat transfer will take place? When in that types of motion, when these types of motion will take place in presence of temperature gradient, that will causes the heat transfer. Is this clear? When these types of motion, which type of motion? Convective motion or advective motion. When the bulk motion is there, and when these types of motion will take place in presence of temperature gradient, that causes the contribution to the heat transfer. And I told you when the only I am bothering about contribution of heat transfer due to purely bulk motion, that's called as advective heat transfer. And when I am considering the heat transfer due to temperature gradient because of combined mode, means molecular diffusion as well as bulk motion, that's called as convective heat transfer. Now it's clear to everyone, yes or no? Because the molecules in the aggregate retain their random motion. The total heat transfer is then due to superposition of energy transport, random motion of molecules, and by bulk motion of fluid. ठीक है? The term convection refers to transport due to bulk motion alone. The term convection refers to cumulative transport. ठीक है? And the term advection refers to transport due to bulk fluid motion alone. Clear beta? So I told you already, the convection, we are especially interested in the convection heat transfer between the fluid motion over the bonding surface, over the solid surface. That's not possible. Actually, madam, we should ignore that calculation. I will discuss. Listen, for example, due to random motion, I am discussing here. Deepika, yes, that's correct. How the fluid exists without having random motion inside them. Obviously, when the bulk motion is there, then obviously there is a random motion. Yes or no? But what I am talking about, when due to random motion the heat transfer due to conduction. Yes or no? Due to random motion, only random motion I am talking about. If the fluid have only random motion, that random motion causes the heat transfer through conduction. By Fourier's law, This is Q equal to minus K A minus K in dt upon dx. Yes or no? And due to bulk motion, the energy transfer is, let's say, for example, try to understand what I'm saying you. Let's say this is random motion is there and this is bulk motion also there. So when here temperature T1, here T2. So due to random motion, the energy transferred by conduction, and this is given by Fourier's law, minus K into dt upon dx. While due to bulk motion, only bulk motion, pure bulk motion, the energy transfer is only due to mCp. Listen, mCpt. Sorry, energy transfer. Yes, m dot is mass flow rate, and mass flow rate involves the random motion. Bulk motion, because density into area into velocity. Fluid is moving with average velocity. This average velocity is the bulk motion of the fluid. So what is mass mCp into T1 minus m dot Cp into T2? This is the energy transfer from 1 to 2. Are you getting a point? Here energy is m dot Cp. M dot is what? Density into gross area into velocity into Cp at T1. This is energy entered at this. This is due to bulk velocity, due to advection only. Is this clear? This is energy transfer to advection. So advection means what? Pure bulk motion, and advection pure bulk motion means that like m dot Cpt. So I am talking about mass flow rate. Only the energy transfer, because as fluid move, this also transfer energy, because here energy is T1, here temperature T2. So when the fluid moves with some velocity, then also there is a energy transport is there. So is this clear? Yes or no? Are you getting a point? So this is the transport of energy, m dot Cpt. This is the transport of energy due to only bulk motion. And when I combine these two, this was the energy transfer due to random motion. And I told you in combined, when I talking about the bulk motion, that will also involve the random motion. So when I combine these two, that is called as convection equation. This is called as advection equation. This is called as conduction equation, and conduction plus advection is called as convection. I told you in the last lecture. m dot Cp is due to bulk flow. Clear, beta? So energy transfer, this is due to bulk flow only, purely bulk flow or purely advection. It's purely bulk flow. This is purely random motion. The random motion plus bulk flow is combined motion, and combined motion is called as convection. Now it's clear to everyone. So what I'm saying to you, through this condition, you are able to understand how the flow velocity, because this mass rate involves the velocity, and how the flow velocity will influence the rate of heat transfer by convection. Yes or no? Is through these all examples you might have seen the flow velocity or flow profile will strongly influence the rate of heat transfer by convection. Yes or no? That's why the role of fluid mechanics is very important in the study of convection heat transfer. Hello, sorry. What I told you, my dear student, that is all for today because I have to go for the flag hosting and I have to present in that ceremony. And I think you got more clearance about the conduction and convection. Do you got more information about this? Yes or no? Did you got? Did you get? Sorry. Huh. So what I'm saying ki it's just an introduction. The first chapter is only introduction. In the second chapter, I will start with the conduction. But tomorrow, I will also discuss more about convection, and then I will also discuss the rate law. That's just like Fourier's law for the conduction. Then which law is used for the convection? That's I call it Newton's cooling law. I will discuss it. Okay. Thank you so much. So in the initial 3 to 4 lectures, you this is simply basics. Then you have sufficient time to solve the backlogs of the fluid mechanics, and you can also practice for the questions.